Hi everyone. Today we are going to talk about 9.2b translation and reflection of log functions. So last time we learned how to translate the log function, right? So just let's see briefly. So you have a log function, log 2x original function, and you put this into the calculator, look at the table, you got the graph like this. And then you are going to translate this function 2 units to the right and 3 units down, right? So 2 units to the right, 3 units down. How do you get the function? X is opposite, Y is the same. Do you remember? So X 2 units to the right, so right side, what do you do? Positive plus 2, but it's opposite. X is opposite, Y is the same. So you write down the function X minus 2, but 3 units down, Y is the same. Down means negative, right? So minus 3. Make sense? And you put the function, but before you get the table, first you should draw the vertical asymptote. So you know the vertical asymptote, but this one was x equal to 0 for original, the log function, right? X equal to 0, y-axis. That was the vertical asymptote. Graph never touches this line, vertical asymptote. But this one, g of x, we translated 2 units to the right. So it will be x equal to line. Make sense? But 3 units down, but it's a vertical line, doesn't matter, right? So how do you find out this line? You can just set this x minus 2 equal to 0 and solve it. X equal to 2 line, and then draw the shredded line, not the straight line. And then we put this function into the calculator, look at the table, and plot the points, right? This is second part. So plot the points, 3, negative 3, 4, negative 2, 5, negative 1, and 6, negative 1, not the 5. And then 10, 0. So you see the graph goes this way, and here go down, go close to the vertical asymptote, but never touches, right? So you do put more points here, go close, and then connect. And put the arrow here, put the arrow here. That's the graph. So this way we translate it, but now I want you to see. What do you notice and wonders? Think about it. This is the original function. And then what is this? You reflect it over y-axis, right? How do you get this function? This one, you reflect this one over x-axis and you get this. Then how, so by the equation, so what should you change to get this function, right? Let's talk about this one. So we have two things here. G of x is log 2, f of x is same thing, log 2x, and you know that this is the graph, right? And g of x is log 2 negative x. This is h of x is minus negative time to the whole function, log 2x. How do you change this? Now let's think about this one. What happened? When x is positive, result is negative, right? So when x is positive, but this part becomes negative, so you get the y value when originally when x was negative, but there was no negative, so your graph, so x can, so you should know that this part cannot be negative, right? X cannot be the negative or 0 also. So to be, you should have have only positive here. So to make this positive, what should you do? X must be negative, right? So this graph, everything moved to this one, but reflect like this. So this is a reflection over y-axis. If you put it into the calculator and look at the graph, you can see it, right? But now if you look at here, h of x here, sorry about this, you multiply now negative to the entire function, the result. So y value, you get the y value here, and then what happens is, let's say when x is 2, when x is 2, 1, right? When x is 2, log 2 is 1. But you multiply negative, so it becomes negative 1. So positive become negative. Positive become negative because you multiply negative to the result, the y value. So this is a reflection over x-axis, right? This case. So if you have a negative outside the function, this is a reflection over x-axis. Simply, if you have a negative in front of x, then this is reflection over y-axis. You put this into the calculator, you can look at the graph, you will see it. You can look at the table simply, right? So look at the graph. If you look at the graph, it will be like this. This is a log 2 negative x. So this one positive become negative, right? Positive x negative, just like this. Y value is same. Make sense? How about this one now? So every value here, negative here, when x this side, it was here, it goes here, right? Everything crossed over the y-axis. But now this one, when you reflect over x-axis, you multiply negative. So y value become the positive, change it, right? Y sign of y value changes. Positive become negative, negative become positive. Make sense? That's why it's a reflect over x-axis. So if you draw the graph, it'll be like this negative go to the positive side, and the positive become negative. Vertical asymptote is the same here. But we learned how to translate also. You can translate, right? So now, so you understand. When you have a negative in front of x, deflection over y-axis. When you have a negative in front of the entire function, then that is a deflection over x-axis. You understand? Now let's have one example with all the reflection and translation. But simply, so if you put this function into the calculator, you can see it, right? You know that. So, but before you put into the calculator and look at the table, let's figure out where's the negative? In front of the entire function or in front of x? In front of x, right? Then this is reflection over which axis? Y-axis, right? Y-axis. So the graph will look like this. And then we translate it. There's no translation for y up or down, only here. So how do you know? You set this equal to 0 and solve for x. That's the translation rule. What did I say? You set these 20 minus 4x equal to 0 and solve for x. That's the translation for x part, horizontal. So reflection over y-axis, we know negative in front of x. And then vertical asymptote, how do you find 20 minus 4x equal to 0? That you translate the vertical asymptote, same with you also translate all other points, right? Also, you translate all other points also by the same translation rule. So how do you find out the vertical asymptote? You set 20 minus 4x equal to 0 and solve for x. If you solve it, what do you get? If you solve from here, x equal to 5, right? X equal to 5. So you should draw the vertical asymptote here, x equal to 5, like this. And then look at the graph and look at the table and the plot the point. So -3, 5. Look at the only integer values, right? When x is -3, y value is 5, plot the points. And 1, 4, when x is 1, 4, like that. And 3, 3, 4, 2. So you plot the points one by one. So 4, 2, you know the points. 3, 3, 1, 4, and the 3, -3. So if you see the graph like this, and then what happening here, you should go down this way, right? Never touch, go close to the line, x equal to 5. And you draw the line, more points here, and then connect. So that's it. So everybody understand? So we'll stop here.